I'm Jessica Kerr, better known as Jessitron. Welcome to ReactRally.
How'd it go?
I'm excited to be here today because I want to talk about the principles of functional programming that also appear in React. And then I'll bring in Elm, which is a whole nother language that takes it even further than React. First of all, I am not a front-end developer. I'm back-end. I do mostly Scala and Clojure. And Jameson asked me to come speak here, and I was like, but my JavaScript is atrocious, and I've never done React. And he was like, that's okay. You know functional programming, and we need to know about functional programming. And he's right. He's right because there are a lot of things in React that also exist on the back end in functional programming, the movement. We're coming to a lot of the same conclusions, and I think that means that we're onto something bigger than either one. I know that React does this because I accidentally wound up in this talk by Adam from Facebook at QCon New York a couple years ago, and he was talking about mobile apps, but he also talked about React and FLUX. It's the same architecture. And I was like, oh yeah, that's totally what we're doing in functional programming too. I can see why this stuff is coming out of Facebook, because Facebook, it tries to model your life. It's incredibly complicated. I mean, these messages are the same as these messages over here, and this news feed is the same as that news feed, which correlates to these other things going on down there. And this person might be in this group, which might affect what ads I see, and who are these kids, and why are they on the roof? It's all a huge snarl, just like my life. Well, I like that in my life, but I don't like that in my software. And this is where we have real scaling problems these days in software. Yes, big data is a thing, and a few people actually have big data problems. And auto-scaling microservices with maximized throughput that scales up and down during the day, yes, Netflix has that problem. But all of us have scaling problems when it comes to fitting our programs in our heads. Because we all want to add more functionality, we want to be more interactive with users, we want our programs to be better and better all the time. And as they do that, they get more and more complicated because what's simple for the user is usually really hard for us to implement. And as they get more and more complicated, they stop fitting in our heads. And then pretty soon, you've got the one developer in the corner that can understand everything, but everybody else is like, oh, don't touch that because it's too complicated. Leave it for her. React and functional programming, both, are about smoothing out this snarl so that multiple people can work on this program so that you don't have to understand the whole thing in order to improve it. You don't have to load this entire app in your head. So if this is your JavaScript application, maybe it's an MVC, and the UFO represents interactions from the user, so like stuff coming in from outer space you don't know when, and the tentacle represents anything from the server and generally the whole rest of the world outside your application or the user. When all these parts are interconnected and any of them can access the server and the user can affect any of them, then you have to have this whole thing in your head in order to safely change any of it. React gives us new ways to break this program apart by giving us new ways to hook it together. Functional programming is the same way. It's about new ways to break things apart and put things together and line them up. I want to distinguish between functional programming as a technique and the larger sort of principles that are coming out of this functional programming, the movement. Nominally, functional programming is about functions. It's about, you can do more than just call one function from another function. You can also declare functions as values. You can pass them to the other function. And at this point, you don't know anymore when that function that you just passed, when that code is going to execute, if it's going to execute, how many times it's going to execute, on what thread of execution it's going to execute. It's less of a problem in the browser where everything is running on one thread in unknown order, but on the back end in Java, there's actual concurrency, and this could be running more than once at the same time, and you wouldn't even know it. Of course, we do this in JavaScript. It's called callbacks, among other things. But the danger is that we've just passed over some code that has access to this scope, and at any time, it could do something. And that's your spooky action at a distance that happens in functional programming. This is it for
the technique of what is functional programming, really. But when we do this, problems start to happen that weren't problems before. Like as a Java developer, one of my favorite things has always been the stack trace, because you can see exactly how we got to this point in the flow of execution. As soon as you start passing functions around,
that is gone. All you get is a few lines and then, oh, yep, we're running on a thread. So functional programming, the philosophy, is everything that we as functional programmers do in order to tame this insanity, in order to isolate the outer space influence from the users and the tentacles of the entire world reaching in, so that we can actually still fit enough of the software in our heads to work on it. I've got 4 principles of functional programming. These are not all of them, but these are common between React and functional programming. Composition and declarative style are totally part of React. And the other 2 are part of React and Flux to a lesser degree. And I'm talking about them today because I think if we really understand why these are important, then we can do them even more and our React code can be better. But I'm looking at this through the lens of first React, which I'm told is not a framework, it's a library. And then Flux, which I'm told is not a framework, it's a pattern. But then I'm also going to an extreme and looking at Elm, which is a typed functional language that compiles to JavaScript and a pattern, the Elm architecture, and of course it has some libraries because it does the same virtual DOM thing that React does. And I want to show you Elm because Elm is like an extreme of this, and if you can do that, then you can take all these functional principles to an extreme in your React code. But first, React. Yes, this is a React conference, so you probably already know all this, but maybe some of you were dragged here by your girlfriend. So here's my understanding of React in 1 minute. You've got a web page. It's divided up into components. The components are defined by a React component, which is written in JavaScript, but returns something that looks like HTML, but is really JSX, and that's fine, that's all mixed up. But what matters is it doesn't actually return what to do to the DOM. Instead, it returns this is what we want it to look like in secret JSX format, and the library does the updates to the DOM to update that component. And then you can build bigger components by combining smaller components, and that's awesome because it's a beautiful example of composition. To a functional programmer, composition means you take 2 of the same thing and put them together into one of that same thing. Like take 2 arrays, concatenate them, get one bigger array, hiding that internal structure and making things simpler at a higher level. React does this. You take 2 components into one, except it's not really that simple because if you say you're building an image and a text into an add component, yes, they're all components, but each of them is also special and requires particular props to be passed down from the parent, for instance. So if you get that wrong, if you miss a prop or something, then there's going to be a problem at some point. You're probably going to get undefined is not a function. You can get that earlier if you get it like when the component is created at test time if you use prop types, which I think are wonderful. One, to detect things earlier, but even more important, to document how to use that component so that people are more likely to use it correctly. So this one might get a width, which if you do, it better be a number, and it definitely gets a URL for the image, and it might get a URL for the link. In Elm, this is taken to a much larger extreme because Elm is a typed language. So each component defines the type of its model, just the same thing as props, really. And it's very specific. So here, I say maybe I'll get a width, and if I do, it's an int. I definitely get an image, which is a URL. The default is not optional in Elm. If I want this width to be optional, I have to be very specific about that. And inside my image component, I am forced to deal with the fact that I might not have a width. I can't get at that int until I give it a default or something similar. I have to handle that. I can't get undefined just because in my test I happened to pass a width that time. I'm forced to do that because the flow of development in Elm is rather different. And this is kind of a warning. Because if you're used to, you write a test, and then it turns green, and you're all happy, and then you write another test, and then that turns green, or you write something and you run it and you see it going and it mostly works and then you tweak it until it all the way works. You don't do that in Elm. Hypothetically, you write some code, you put it in a .elm file, you compile it into elm.js, include that into your index.html, and then you go. But really, no, you try to compile it, and then you fix a compile error, and then you fix a compile error, and instead of a green test, or, oh look, something worked, you get a different compile error, progress. So you kind of have to settle for that. But it turns out to be awesome, because eventually, once it really does compile and you run it, it actually works. Not just part of it, the whole thing. And it doesn't let you forget those niggly little bits. Fantastic also for changes, because if you change something down here and you need to propagate the new data all the way through, it'll tell you where you forgot. What you never, ever physically cannot get is undefined. It doesn't happen in your Elm code. And that's one of those things with functional programming. If we want to scale what we can think about, we have to narrow what we have to think about for any individual part. In your Elm code, you don't have to worry about getting undefined. It's just not going to happen. As opposed to, here's your MVC app, and this one has like two-way data bindings, and it's reading the DOM, and the DOM is updating the state, and this is like a party. So it's kind of like how at a party, you know, one person says something and the people around them might hear it and they might react, and then that might change what they do with other people. And it's all very interactive and unpredictable and spontaneous. That's awesome at a party, and it is so not what I want in my software. I want it predictable. I want one thing at a time. I want to know what's going on. I want to be able to see that and follow it. Now on this side, with the user, yes, totally keep the party. I want them interacting with the DOM. I want them to feel like they're working with my application and things are responsive and cool. But on the back end, I want some sort of predictability and smoothness. I don't want a party. React totally helps with that. In the one direction, you don't update the DOM. You just say what you want, and all the components say what they want, and then all of that gets rendered. Yay, it's so awesome that this is fast enough that we can do that, and in fact, even faster. In the other direction, we'll get to Flux in a minute. This is a perfect example of declarative style. Declarative style says, don't tell me how to do it, just tell me what you want, and let me figure out the fastest way to do that. If you map over a list, that's declarative compared to looping through it each time. So this is a very big part of functional programming. My husband works like this too. He says, you can tell me what to do or how to do it, but if you want it done a particular way, do it yourself. As an industry, we're finally tired of doing it ourselves. And that's why, one reason, React is so popular. Because it really is better to say what you want. And it's much more testable. Because that what you want is data that you can look at. You don't have to ask, okay, now what happened in the DOM? This declarative style is exemplified by the render function, which is at the center of a React component. The render function, and this is all over the React documentation, even like the very front stuff, is supposed to be a pure function. I don't like that word. It's considered it takes as its input the props and the state, even though it technically pulls those off the component. Those are its official input. And all it produces is the rendering instructions, that JSX of what we want in the DOM. This is awesome because it's data in, data out. It never accesses global state, including anything in the component besides props and state. That's all it gets, that's all it touches. It never looks outside. And it never modifies its input. That's just rude. So it doesn't change its props or its state or anything else in the component. It doesn't affect the world at all. It doesn't access local storage. It doesn't do any AJAX stuff. Sometimes we compromise on printing to the log, but even that's discouraged because the whole goal is you want it to not matter how many times this function is called. And you want to know that for the same input, it always produces the same output. That makes it super duper testable. And testable is fantastic because it lets us be sure that we were right without a bunch of clicking and trying it over and over again. All this gets down to things we don't have to think about when we're worrying about a piece of code. When we do all that stuff, what we have is isolation. Our function is isolated from the world around it. I don't care how many times it runs. I don't care what thread of execution it's on, because no matter what is going on in the universe, my function does the same thing. It can have lots of it, and it still does the same thing. Super predictable, yay. Now there's a caveat. If I pass something into my function, say this is like an array of options that's coming in from the parent, and say the parent then goes and decides it's going to add something to that array and modifies the data that it already passed to me, well, crap. We just blew it. There is no isolation. Because something outside is affecting this data that was passed into me and the world has intruded. That's why immutable data is a big deal in functional programming. You can use that in JavaScript, which is awesome, because once you have immutable data in, data out, then you have a predictable piece of code. What we're doing here is we're tying our hands to free our minds. We're saying, I'm not going to change the data. Even if you don't use immutable.js, you can still choose not to change it. We say, I'm not going to access the server. We say, I'm not going to dig around in the global state or change the local storage. And you can make most of your code work like that. And that's all stuff that you don't have to think about. And that lets us, this phrase annoys me, but here it is. Functional programmers love to talk about reasoning about code. And I hate this phrase because everybody uses it to mean something different, to mean like whatever techniques they use. But I don't care how we reason about code. I do have a definition for what we're accomplishing. And that is to predict what our code will do all the time. Not just, oh, look, I'm playing around with my web page and I go and I change the width of this div from 50 to 48 so it works now. No, that is the opposite of reasoning about code. Reasoning about code is about all the time. And you can do that when you limit the influences on your function. You choose to limit where you change the data or whether you access the server. And then it's actually possible to predict all the time. So that's totally useful. And it's fabulous on the render function. Unfortunately, that is not the only function on the component. And there's all these other components that are changing the state and make my React component a special snowflake. Each instance of it is special and different. And then sometimes you can even have like the on-click methods, bringing the UFOs to change your state on that too. Well, at least Flux gets rid of those red arrows. So now it's time for 1 minute of Flux. This is my understanding of it. Okay, you've got your components, and they produce the definition of the view, which goes to the browser, which interacts with the user. But when the user pushes that button, it doesn't go straight back to the component. No, it goes all the way over this way, to the action creator, which sends an action to a dispatcher, which one at a time sends each of these actions to one or more stores, which is in charge of the data, so it updates its internal state, and then goes through this elaborate callback dance with the controller view, which gets this new state from the store and passes it down as props to the components. So when that UFO flies in, at least I know where it's going. It's going over there. And that's going to trickle down through all these things until finally the components are responsible for the view. And we do the same thing with server interactions. We can choose to pipe those through the action creator so that the results come back as actions and go this way. That's a big deal. This is the sanity on the other side of the application browser party. It's a flow of data. And I think a lot of the techniques that we use in functional programming really boil down to removing circular dependencies. Two-way data binding, oh, it's the tightest little circular dependency you could ever hope for. And they get to be everywhere. Anywhere there's mutable state, then anything that might mutate that state is dependent on everything else that might mutate it or use it. There's circular dependencies everywhere that you can't even see. Flux is beautiful about making it one circle. The goal is, yes, there's a circle. The user is in that circle, but there's only one, and everything comes through. And if I say something at the party, I say it, everybody hears it, then somebody else says something, and everybody hears it. Now that would be a totally lame party, but it makes for a great application. In Elm, this is taken to an extreme because in Elm, everything is data in, data out. All of it. Here, the flow looks like this. You've got an action coming in from outside, from the spaceship, and it goes into an update method which produces, here's the next model, the next state for me and all my subcomponents. And then because the update function is stateless and the component can't keep track of that itself, the calling function just passes that back in next time with the next action, and the update function says, okay, Here, this action happened based on this previous state. Here's the new state. And each time that new state goes to, I'm totally backwards. Each time that new state goes to the view function and then out to the browser. That's the data flow. And this is, let's see, so you've got an update function that knows how to change state based on things happening. You've got an init, just produces the model to start with. And the view function, which is the render function. Oh, and if you want to talk to the server, well, you can't do that in your update function, but you can return what's called an effects. It's a set of instructions. It's data that say, hey, please go to GitHub and get the next batch of events for this repository that I'm displaying. And those instructions go back out through a special port, and the results come back in as actions, and the flow continues. So this is completely testable because it's entirely data in, data out. And in order to show you, and then we arrange them like this in a component. The init and the update and the view are all in the same module file. And you probably define a model type and an action type. And in order to show you an example of this, I want to show you my little app, which is going to confirm you will be completely certain that I am not a front-end dev. Because CSS is beyond my skill level. Okay, so here is, if you go to this repository and star it, your picture will appear on the big screen. This is like, hey, what's going on in my repository? And here it is, it goes back and it gets one page of events, and it puts them up here and puts a little picture and highlights the person that's currently active. And then if I go mouse over one of the pictures, it'll be like, oh, you want to know about, here's me, this is the bird. And it highlights the events that are mine. I can mouse over here, and it'll say who that person was. There's my daughter. She created a GitHub account just so she could start this repository so she could be on the screen. Awesome. Hi, everybody. So this is Sidron, and it's got 4 parts, right? You've got the header, and then this little form so you can put in your repository, and then this ticker of incoming events, and then all the people. If you create issues, that works too. Okay, back to Keynote. When we look at this, say, for instance, just this event ticker part, the model for that has the recent events, and it's got a list of events, and a highlight, because we might have a person to highlight, but we specify that it's only maybe a person, because at the beginning there isn't someone. The init function initializes that with an empty list and nothing. And then the update function, so I've got a layer in my app that hits GitHub with an effects, and comes back with like 30 events, and it breaks them down 1 per second based on other actions that come in that say a second passed. Okay, here goes another one to all the components. So this component receives a single event, which it can add to the list. Yeah, the code runs off, but it's not that important. And it receives a person of interest, which changes its highlighting technique. And that's it. That's the whole state, and that's what gets updated in the update. When I want to build components in Elm to compose them, to put them inside each other, each of these init, update, view functions, whichever ones I've defined for this component anyway, call through to the childs. So in my app, the outer view method looks like this. It's a div that's composed of the header and the input and the ticker and the people. And that's it. It's a little more complicated than React in the sense that in React, if you want to use a component, you put that in your render method, you reference it there, and that's kind of it. Here there's multiple places, but I want to contrast Elm components with React components. Specifically, the Elm component has these 3 functions in it, but those functions are not entwined at all. They're each independently data in, data out. You could put them in different files. You don't, just because you want things that change together to stay together. But unlike React, you've got all these other lifecycle methods that are changing the state, and they kind of get wrapped up in each other, and you have to call them in the right order. That is not true in Elm. There's no required order. But with the composition, let's see if I've got that picture. Yeah, when I hook my whole program together, the data is flowing through the init methods, and then through the update methods, and then through the view methods, and then out to the user who clicks a button, which comes into this. That's supposed to be a mail slot. And the actions come in there, and I haven't drawn all the plumbing. But my main module, which is also data in, data out, defines a bunch of ports to the outside world, and that's the only place that the outside world happens. It never intrudes on my Elm code, and if I'm going to get an undefined, it's going to be in that port because JavaScript's running there. It's not going to be in my code. Incidentally, you can combine React and Elm. My friend Richard at work, he runs React and Flux that calls through to Elm, and you can also go the other way. There's a post on that in the resources. And the other reason you should use Elm, the last reason, is because it's written by Evan Shaplitsky, and Evan is always smiling. He is an amazing language author and amazing language steward because he's very focused on Elm being user-centric, and by users he means you and me. So the compilers are actually friendly. They're like, hey, I don't know this function, but maybe you meant this one, or like, hey, I see these two types and they don't match up. You've got something that doesn't fit together. It never says, undefined is not a function. Yeah, I knew that, JavaScript. Thank you. Also, Evan is a great community leader, and he really works on making Elm friendly and the community good and the user groups about building stuff, not about let's take a bunch of experts and make each other bigger experts. It's about let's help everybody build more things without getting undefined. Also, while Elm doesn't do everything that React does, it's not like you're going to go out and replace all your React code with Elm in a very large app right now. If you play around with it, you will be forced into using these functional principles and more strictly. And once you're forced into that, once you're used to having your hands tied by the language, then you can choose to tie your own hands exactly as much as is necessary and helpful in your React app. You'll be ready to compromise because you'll know exactly what you're giving up. When you are in React, I recommend prop types and immutable data when you can, or else just don't change it. Use array.concat instead of unshift, that kind of thing. You can use Flux, yes, or even better, you could use Redux, which is based on Flux and the Elm architecture, but it's in JavaScript. So when you're looking at Flux, you might want to look at that one. And finally, keep all your service calls in one place. Remember that you want all your octopuses and your UFOs under control so that you can have one thing at a time happen in your app and keep it straight, keep it smoothed out, keep it scalable in your head. I'm Jessica Chan, I work at Monsanto. I also have a Pluralsight course, and you should make one too because it's a cool company and it's pretty lucrative. All the resources that I've thought of to include in this talk, including the slides, are available in the README of my little sample repo right there. Thank you.